Good morning everybody. Today we will discuss the remaining part of the welding and joining process for non-metallic materials. So, one of the such important welding or joining process for the non-metals is the laser transmission welding. So, laser transmission welding it is like that there is a two component, mainly it is applicable for the plastic materials. So, we can keep the upper side the transparent material through which laser beam can passes, and at the bottom side we can put the other different grade of plastic material, such that at the interface there may be the heat generation, such that the two components can be joined here. So, either we have to choose the material in such a way that the top materials there is a transmission of laser will occurs, that means without any absorptions by the first layer, but whatever absorption will be occurring, that will be in the second layer. So, sometimes if both are transparent material through this specific wavelength of the laser, so in that case maybe in between some absorbing layer can also put, and that absorbing layer basically the amount of the laser energy will be absorbed at the interface, and then it will melt the surrounding area, and by applying some clamping pressure or applying some forces for a specific time period, then welding of this joining can occur after cooling down of this molten steel. So, this is as simply this is laser transmission welding. But sometimes this transmission welding is also known as plastic welding, laser plastic welding, or through transmission welding, and sometimes laser polymer welding. So, basically this welding process has been developed in specific application for the polymeric material. So, basic principle is that transmitting laser radiation through one piece of plastic materials to create a weld. So, once the transmission come just through one layer, then some energy in between these two layers have to be released, such that at the interface there may be joining of between these two components can be done. So, here if you see the figure, that transparent laser, but that transparent that laser transparent through this material, that is it depends upon the wavelength of this specific laser, which laser is used here, and it is a infrared or near infrared laser. Mostly transmittance happens for a different types of the polymeric materials. So, if you look into further, the process requirement for the laser transmission welding is that first is the transmitting upper part. The upper layer or upper components needs to be transparent to laser wavelength. So, actually the transparency of the laser light depends on the wavelength of the laser specifically used for the welding process. So, normally for example, 808 nanometer or 980 nanometer, these two lengths are normally we use the wavelength of the laser in that range, and that is in the infrared or near infrared spectrum. So, in that range if we use the laser, and that laser is specifically applicable for the laser transmission welding. So, once transmitting upper part, next component used to be the absorbing lower layer. So, absorbing lower layer, so that we have to choose the lower layer component in such a way that that layer will be able to absorb the laser energy, laser light energy, to generate the some amount of the heat at the interface. So, sometimes if both are both polymeric material are transmissive in nature with the specific wavelength of the laser used. So, in that case sometimes some additive absorbing additive such as carbon black doped at a rate of around 0.5%. That means, that carbon black can be used at the interface layer. So, that interface layer, that carbon black actually acts, basically absorbs the laser energy and creates some melt push. So, once the transmittive layer and then absorbing layer, and after this the third process requirement here is that clamping and contact. So, contact should be is the is a very the gap between these two components should be very low, such that once the thermal energy is released on the at the interface, that means either in the absorbing lower layer, that means lower component or on the interface. So, then gradually heat will be conducted to the upper layer. So, that amount of energy will be also at the same time will be able to melt the upper layer. Then only to make as a consistent contact between these two components, there is a requirement of the application of the some amount of the pressure between these two. So, after cooling down this component, the strong weld bit or can be formed for this polymeric material through laser transmission welding. So, material compatibility, you can see most of the plastics to be joined require similar chemical compatibility. That means, two components have to be chosen in such way almost similar compatibility should exist. So, at the same time the two materials having the melting and softening ranges for both the plastic should be at the same time or may not be, that means there may not be much difference in the melting point between these two components, which is supposed to join by laser transmission welding. So, if we see the typical materials applied or weld or joined by this laser welding process, it is that nylon different that PA6 and that different variants can be joined, then PP, then PC, ABS, polyester. This is the short form of this different polymers that can be joined while using the laser transmission welding. The PTFE and that PMMA, all these type of materials can be joined by using the laser transmission welding. But if you look into that advantage, that means with respect to the other processes here or other welding processes. So, here you can find out that there may be some minimal mechanical stress. So, mechanical stress will be very less, because in this case there is a difference in the thermal expansion coefficients, or maybe is the very less in between these two. So, there is a less chance to generate large amount of the mechanical stress. Precise energy control, since we use the laser as a source, then we can very precisely focus on a specified space in the therefore, it is possible to control the amount of the energy released at the interface. Then very strong and durable welds can also be done using this process, by this process, and of course, minimum flash and particulate development is very negligible in this process, and this process is very clean process also. And the weld joint, that means heat affected zone, or we can say that by this welding process can be confined into a very small place. And finally, it is a very fast process. So, therefore, very less welding time is required for this. So, these are the typical advantages of using the laser transmission welding for polymeric material. But if we look into that other application area of laser transmission welding, here see there are several applications. So, automotive, that sensor housing, lighting, instrument clusters, interior panels, fluid control devices, all this in automotive sector, we can find out the application of the laser transmission welding for this material, for this area. And then in medical devices, there is a huge application of the laser transmission welding, specifically when you try to join, we use some polymeric material. There microfluidics, fluid control devices, that means medical instrument or medical devices, when there were use of the plastic components, then we can use the laser transmission welding in that area. But overall, this process is mainly confined to laser polymeric material, apart from, but in other dissimilar combination of materials can also be joined. So, we will be discussing later on this. Now, after laser transmission welding, we will try to look into that the glass welding. So, this is the glass, we know it is a very brittle material. So, definitely there is some issues of welding different kind of glasses. Let us see that what way we can, what problems, what are the methodologies can be used for welding or joining of the glass. So, definitely glass having the melting range, that is called the glass transition temperature. So, there is a range of temperature through that is called the glass transition, but the heating when the heating of the solid material into this range, normally glass becomes softened and becomes more flexible, and such that after bringing in this state, then it is possible to join two glass components by simply application of a small pressure within a contact, then glass can be joined. But if you look into that, it is a more precisely that when it cross the glass transition temperature, it becomes very thick. Slag is kind of viscous liquid, viscous liquid, that means in this case it is having the very little surface tension, that means surface tension is reduced in this with the application of the heat in the glass. So, then after that it becomes very honey like, that is very sticky. So, welding can be done very readily by simply pressing the two melted surfaces together. And then the two liquids generally mix and join at the first contact when they are in contact with the application of the heat. So, therefore, after when we follow the cooling period through the glass transition, then the weld pieces will solidify and then one solidify and then it looks like the one solid piece of the amorphous material. So, the welding or joining of the glass process is almost similar to other conventional welding process, but the difference in that sense glass welding is that the material properties are completely different from the metallic materials. So, therefore, glass whatever properties changes, that is through the glass transition temperature range, and then after melting it takes a kind of shape of viscous liquid, and then when they are in contact they can readily join between the two components in the glass. So, finally, after solidification also again it goes through the transition temperature. So, properties can be changed when it is processed through the glass transition temperature, and one solid piece can form in the as a amorphous material. We know that glass is one kind of the amorphous material, not the crystalline material. Now, what are the methodology, that means what type of the heat source can be used in case of glass welding. So, normally welding with gas or oxy-gas torch, hot oxy-gas torch or using a furnace, these are the typical source of the glass, and it is easily to locally applied in certain part of the glass, and then melting of the glass happens and finally join between these two components. But typically the melting of the glass is often quite high. Therefore, the furnace is one of the choice of heating the act as a heat source for the welding of the glass materials. Let us look into that, but this range of the melting, it depends on the melting point of the, that means weldable liquid in the form of the weldable liquid are different for the different types of the glasses. If we look into that, lead glass, that is commonly known as crystal, becomes a weldable liquid around 870 degrees centigrade, but if you look into the quartz glass, that is also fused silica, it can be the weldable liquid around the 1650 degrees centigrade. So, although material but different types of the both are glass, but the different types of the glass there may be the huge difference in the melting point temperature, such that there is a difficulty in joining the two different grades of the glass may be treated as a joining of the two dissimilar materials, since there is a huge difference of the weldable liquid between these two different types of the glasses. So, mostly the tube, sometimes tube are attached with the glass, that means they are such that this allowing to make blown into the various shapes. That means that weldable, that means liquid weldable in the form of the weldable liquid, when it is formed in the weldable liquid in glass, then if we use some tube to try to make it the blow into the, then it becomes various shapes like such like bulbs, bottles and the tubes. These are the typical manufacturing technology using the glass. But when the two pieces of the liquid glass are pressed together, then they usually weld as a readily, they join this readily. But definitely although there is a welding or joining of the glass technology, welding of the glass or two different grades of the glasses are well established, but there are some limitation of the glass welding process. First is that since we know that glass is very brittle material in its solid state, and therefore, there is a highly chance to form the cracking during the heating and cooling phase. So, because cracking since glass is very brittle material, so there is a hardly it is very difficult to absorb the uneven thermal expansion during the heating or during the cooling phase. So, there is a highly chance to form of the cracking phenomena during the processing of the glass, specifically when you try to do the welding of the glass. So, we can take an example that quartz has a very low thermal expansion coefficients, but while the soda lime also soda lime glass having very high thermal expansion coefficients. So, it is usually in this case the joining of these two types of the glass is difficult, but therefore, it is very much important to closely match their coefficients of the thermal expansion to ensure mainly not to occur the cracking during the welding of the glass components. So, other significant issues of welding or processing of the glass is that during the cooling phase we need to follow very slow cooling at the processing, and at the same time that it should follow the slowly cooled very slowly, and at the same time the cooled evenly through the glass transition temperature range. So, that is followed and that is basically controlled, and this process is normally called as annealing process, and that annealing process is helpful to relieve any internal stresses that mainly created by the temperature gradient. So, therefore, the most significant component of the glass welding or maybe limitation is that very controlled cooling is required in this press, and very careful in the sense that glass actually is very brittle material. So, even it cannot absorb a small amount of the thermal expansion. So, that is the only limitation for the welding of the glass components. So, we can see the typical application of the glass welding, that is the glass blowing. So, that glass blowing means in this case that but liquid at the liquid state of the glass, if we put the by using some tube, if we try to blow this one, then we can make the different shapes. It may be circular shape or spherical shape, or maybe some tubular shape, or maybe cylindrical shape. So, different shapes can be formed, that is the that is generally follow we can find out during the processing of the glass welding. So, therefore, construction of the lighting or flash tubes, in this case also we can find out the application of the glass welding, very scientific equipment, manufacturing of the dishes and other glass wires, this the typical application of the glass welding. Moreover, glass casting for the joining the halves of the glass molds, making it such as bottles or jars. Here also we can find out the application of the glass welding. Next, we will try to discuss that welding of the ceramic materials. So, definitely one of the non-metals, important significant non-metals is the ceramics, and there is several developments of the different kind of the ceramic materials. So, ceramics having the high potential because of their increased toughness, mainly the high heat resistant capability and non-catastrophic failure behavior. These are the typical driving force for the huge application of the ceramic materials in several industry. But if we look into this figure, here you can see that strength to weight ratio and the operating temperature for the conventional materials, mainly titanium and the super alloy, that actually exists, it is a narrow zone. In that sense, with respect to that, the processing of the ceramics required relatively at very high temperature, even for it is more than the metal matrix composites materials processing temperature in terms of the processing temperature. Then ceramic composites and carbon composites, all we can find out carbon composites. Here also we can find out the processing temperature is very high even as compared to the ceramics, but as compared to the common metallic materials, we can find out the processing temperature is very high in case of ceramics. Now, what are the typical joining or welding techniques for the ceramic materials? So, here you can see that electron beam welding, laser beam welding, friction beam welding and the diffusion welding, these are the main processing techniques for the welding of the ceramics. So, high beam energy actually restrict to application of the high beam energy is basically restricted to the small components of the ceramics. For example, that can be used with the ceramics and only for the ceramics which is defined melting points, for example, the Al2O3. So, therefore, the processing of the welding or joining of the Al2O3 in this case we can use the high beam energy, that means electron beam energy or laser beam energy. But in other cases, for example, silicon carbide and silicon nitride, in these cases the use of the high beam energy may not suitable for this kind of material. So, mainly high stresses caused by the severe temperature gradients can easily damage the ceramic joint. So, therefore, we should have been very careful by choice of the material and the difference of their mechanical properties when we are supposed to join the ceramic components. So, other significant joining methodology for the ceramic components is the either the similar joint configuration or dissimilar configuration with the metallic materials by the diffusion welding. So, in this case in the diffusion welding, but in diffusion the main difficulties is the due to the necessary pressure need to apply and need to apply specifically for a larger components, and there is a time requirement. So, normally diffusion welding process takes the huge time. So, high equipment costs and long processing time or long joining times basically leads to the high production cost for the ceramic components. Therefore, most economically for the welding of the ceramic materials, generally people follow the brazing process, because brazing is the most economical joining process for ceramics by simply using the brazed components, both ceramic braze as well as the metallic braze are used in this case. If you look into the typical properties and application of the ceramics, that definitely ceramics having the very high temperature resistance and extremely high hardness and low electrical conductivity and the high thermal insulating properties, high chemical resistance and also lower density as compared to the metal. So, all this specific advantage of using ceramics. Therefore, nowadays we can find out there is a huge application of the ceramic materials, but in that sense the development or maybe ease weldability of the ceramic materials is not up to that limit what we found out in case of the metallic materials. So, definitely, but still there is a development of the joining or welding of the ceramic materials also happen, just we discuss based on the different high we generally use the high beam energy diffusion welding, and sometimes we use the brazing process also for joining of the ceramic components, either ceramic to ceramic or ceramic to metals. But there is huge application of area of the ceramics. So, we can see that excellent properties are the very main reason for applying the technical ceramics in the wide range of the fields of the electronics, automotive and the chemical industries. These are the areas where we can use the typical application of the ceramic materials. So, therefore, in aerospace technology, metals sometimes some components of the metals can be replaced by the ceramic component, because in the aerospace industry goes through a very at that high temperature range, and high density metals may not be suitable or create some problem. Therefore, in that sense the ceramic is the most alternatively used in that place. So, therefore, because ceramics is having very good high heat resistance properties. Of course, ceramic welding is also applied during the furnace operation also, simply by conveying a dry mixture of the refractory aggregate and oxidizable particles actually kept together through specifically designed water and water cooled lenses. So, in that channel we can put this ceramic refractory material, and then ceramic welding helps with the no minimal loss of the production and no minimal loss of the production, and at the same time extending the furnace or the vessel life. So, therefore, in the furnace operation we can find out simply welding of the during the furnace operation we can simply put the ceramic welding is a efficient way without loss of the production, and at the same time it actually imparts the life of the furnace or vessel life. But if we the industrial practice normally use the materials like the monolithic ceramics, for example, either oxides or non-oxides are mostly used in the engineering design. The oxides are mainly Al2O3, aluminum oxide and zirconium oxide, ZrO2, but non-oxides are mainly silicon carbide and silicon nitride Si3N4. These are the typical materials we use most of the engineering application ceramic material. But limitation of the process is that high expenditure of the preparation of the joining part is required specifically for the diffusion welding, and high expenditure of the equipment also if you try to apply the electron beam welding. In this case the electron beam welding process is very costly process, but joining techniques, although using the brazing is the most economical way we can find out for the for ceramic welding process, but brazing is limited because the ceramics lost their specific superior properties. So, that means, in that case when you try to use the brazing, the weld part between the two ceramic components, that welded part becomes the weaker as compared to the base material. So, therefore, very precise applications brazing may not be usable, but at the other sense the brazing is the most economical way to joining of the ceramic components. Limitation, other limitation, the difficult to process and the big and small resistance to the thermal shock. So, it is very difficult to process the ceramic materials, because most of the cases we can find out the ceramic is also brittle in nature and small resistance to the thermal shock load. So, in that sense it is difficult to process. So, since ceramic material is porous, sometimes porosity tend to create some problem during the welding, and we can find out some marks of the porosity, or we can find the only the porosities at the weld joint during the fusion welding of the ceramics. So, since ceramics having the low thermal conductivity as compared to the as compared to the other material, and therefore, with the high thermal expansion stresses in the material can occur, and that actually leads to its destruction. So, thermal conductivity low and high thermal expansion, with this combination there is a failure of the weld joint may happen during the processing of the ceramics. So, that is the one obstacle or one difficulty of the processing of the ceramics. Now, there is a nowadays there is a huge application of the plastic components, specifically biocompatible plastic components with the combination of the metallic materials. We can find out this some requirement in specifically in the medical instrument or medical industry. So, therefore, joining of these two components, plastic to the metal, is having some significance. But if we look into why there is a need for joining of the plastic to metal, and if we look in the several points on that this, although this is a dissimilar combination, have increasing from the point of view the energy consumption, environmental concerns, high performance, and from the point of view of the cost saving. So, mainly metals usually have been selected since there are some specific superior properties, for example, best high thermal conductivity, therefore, high machinability. So, from that point metal choice of material is having some advantage of this or based on their properties, but at the same time plastic also having some other excellent properties like corrosion resistance, insulation and the lightweight, and this all these three properties are definitely comparable as compared to the metallic material. So, metal is having some certain advantage or at the same time using the plastic also having certain advantage or having very certain properties. Therefore, combining these two brings a huge difference in the properties. So, therefore, joining or welding of these two components metals to plastic has a huge difficulties, because their properties are completely different, and not only that they are different, not only the mechanical properties, even thermal and chemical behavior are also different. So, therefore, we can take an example also. If we see that there is a two material PET and stainless steel, and we suppose we want to join these two, one is the plastic and another is the metal stainless steel. So, here we can see there is a huge difference in the melting point temperature. One is the 243 to 260 degree centigrade, another is the around 1400 degree centigrade. So, there is a huge difference in melting point. Thermal conductivity also having huge difference, one is 0.24, one is the 138, other is the thermal expansion of the coefficients. Here you can see that one is the thermal coefficient for thermal expansion is 6 into 10 to the power minus 5, another case is 1.72. So, although there is a huge difference in the mechanical properties, so therefore, it brings it is very difficult to join between these two materials, but there are several methodologies also developed for joining the plastic to metals. One is this polymer metal hybrid joints are found using the various joining techniques. Simply use some adhesive bonds, simply using some glue or some mechanical tools, that is the most convenient way to join between these two components. But use of additive bonding for joining aluminum and PTFE we successfully achieved, but only after treating the very good surface treatment with sodium, that we observe using the adhesive between the joining between aluminum and PTFE. So, therefore, surface preparation is one extra requirement in this case. Otherwise, bolted joints using some mechanical instrument. So, simply bolted joints of the carbon fiber reinforced epoxy CRFP and the titanium, that also having results in the increased joint strength, but definitely they are having some drawbacks such as processing time is low processing time, high production cost, limitation of the shape and size. That is the main obstacle using some means of the mechanical joining of these two components. But difficulty is that adhesive bonds, although we can use, or glue we can use more easily for joining these two components, but problem is that it is a environment restriction is there on the emission of the volatile organic components, and at the same time there is a difficulties of the mass production using this adhesives or glues, and of course, there is some lifespan of this glue. So, in that sense it is limited. Other way to improve the quality, production time, because that is rate of the production, reliability of the dissimilar material combination, in this case can be used the laser beam welding and the resistance welding. These are the mainly two welding processes can be used for the joining of the plastic to metal. So, of course, if we look into the resistance, that TPC, that is the polymeric material and joining process, such mechanical fastening and adhesive we can use it, but point is that here if we use the mechanical processing we can find out the stress concentration due to the hole drilling, that is the one thing, and there is a extensive surface preparation also required. So, that actually incompatible for the mass production requirements. Alternatively, that means to avoid this situation, the resistance welding can be used for joining the metal to plastic. Therefore, this when they apply to TPC proved to produce the close to parent strength joint, because when you join these things in the short processing time using the resistant welding process, we can find out that joining strength is very much close to the parent metal, maybe in this among these two metals and the polymer, in which cases the strength of the base metal component is low. If you can compare, almost similar range of the weld joint strength can be achieved by joining. At the same time, additional advantages like reprocessability, recycling, online monitoring, automation and cost efficiency, all in that aspect, the resistance welding of this combination metal to plastic is the better choice as compared to the other using some adhesives or using some mechanical joining. Laser advantages of the laser welding is known to us also, because laser welding, it is a high precision manufacturing for the material processing and for the small parts and geometries, and laser can be focused into very small size, which can be used for joining of the different components, and even for the micro components can also be joined using laser. And other advantage is that laser is a non-contact process. So, therefore, this is an added advantage of using the laser in specifically in case of the welding of the different materials. So, therefore, apart from the resistance welding, laser transmission welding is the another option for the joining of the metal to plastic. So, here we can see that already we have discussed about the laser transmission welding or laser transmission joining. In this case, the polymeric materials normally we can keep on the as a transparent material on the upper side, and lower side if we put the metallic material. So, then therefore, at the interface, so heat will be released on the metallic material, and then we can join by the laser transmission welding. Specifically easy to do that in joining between metal and the plastic. So, it is observed that joint strength and the bead width, that means increases as a function of the increasing the thermal input from the in the laser transmission joining. So, therefore, if you increase the thermal input, then strength can be increased, but at the same time if we increase too much, then there may be the degradation of the polymer and bubble formation, explosion, that can also happen. So, we need a optimum amount of the energy such that the joint strength can be optimum between the polymer and the metal. But in one side it is called laser transmission welding, but in other side from the that is called the conduction welding, CJ conduction welding. So, in this case the joint strength and the bead width increases as a function of the increasing thermal input as well, but further increase in the thermal input causes a decrease in the strength. So, therefore, some optimum amount of the thermal input is required to get a good joint between the metal and the plastic. So, here you can see that joining schematic diagram in the laser welding experiment, that is the welding between the polymer to metal, is a similar configuration to the laser transmission welding. Here you see the with just biocompatible plastic, normally we can put in the upper side, and in the lower side this is biocompatible plastic, and the lower side is the metal, such that laser beam processed through the transparent biocompatible plastic, and heat is generally released at the interface, and this is the clamping plate to keep on sufficient pressure between these two contact surface, and that actually after cooling, then finally joint weld joint is formed at the interface. This dissimilar material, there are several combination of the material, normally we can found out in the literature that the biocompatible plastic to the metal. Here you can see that PET film to the stainless steel can be joined using this material, using this process. Then PMMA and stainless steel 304, PET and aluminum alloy, PET and different grade of aluminum alloy, stainless steel as well as copper can be joined using this process. Carbon fiber reinforced PEI and aluminum substrates can also be joined. Then thermoplastic matrix composites TPC and stainless steel can also be joined using this process. So, therefore, we can find out there is a several combination of the polymeric material and the metallic material, and they joined by the in the mode of the laser transmission welding. So, you can find out the typical application of the this biocompatible plastic to the metal in electronics industry, aerospace industry, medical, automotive industry, and therefore, industry where there is a requirement of the particularly there is some components of the hybrid material fabricated with the hybrid material. So, in that case this process is mostly suitable, but most specifically the laser transmission welding we can find out the medical industry, that is a recent trend then gradually moving, because with the miniaturization of the components in the medical industry. So, there is a increased use of this laser transmission welding in case of medical industry. So, now up with this all these different type the although we have covered, but very few specific welding or joining techniques for the non-metals, and if we summarize for the different joining techniques or some issues in the welding and joining for the different non-metals, we can find out that in the very first we discussed that welding of the thermoplastics, and that is mainly developed by the hot gas welding, hot plate welding, ultrasonic welding, spin welding, vibration welding, friction stir welding and radio frequency welding. These are the typical methodology followed for the welding of the thermoplastic material. But among that methods welding techniques, the ultrasonic welding of the plastics, that is the in this case more precisely controlled in the very small zone and very thin plate generally required, and the weld cycle time is very less in case of the ultrasonic welding of the plastics. Now, after that we discuss the ultrasonic welding, ultra short pulse laser welding, and that ultra short pulse laser welding is very much suitable for the highly transparent material, because if that transparent material we don't use any kind of conventional laser welding process, and in this case if we use the ultra short pulse laser. So, that ultra short pulse laser when it is processed through the transparent material. So, there may be the possibility of the absorption of the laser energy at this point, and specifically this happens in case of the ultra short pulse laser. So, that is the one typical points to be remembered when case of the application of the ultra short pulse laser. But of course, there is an alternate of using the ultra short pulse laser, that is called laser transmission welding, that is also developed, and in that case also we can use the one transparent material, but if the using the specific laser at the and with the certain wavelength, if that laser passes through the both the material. So, in that case some absorbing layer can be put between these two transparent material, and then that absorbing layers some absorb the laser energy, and that creates the heat at the interface, and that is responsible to join the two transparent material. So, in that way laser transmission welding is also developed and using the conventional laser process. Then glass welding, although very limited welding process exists for the in case of the glass welding process. So, here mainly we can use that oxy gas torch or furnace to brings the flexible or maybe to brings the viscous nature of the glass, such that when they are in contact at this mode, when they are in contact to components, then the readily joint can be formed, especially in case of the glass. But overall we can find out the welding of the glass, there exist very limited techniques. One of the most economical method for the joining ceramic is the brazing. Of course, this technique having one economic brazing is the one of the economical technique, but it is having some other limitation also. Then dissimilar welding between the plastic to metal, normally we can find out most of the cases we can find out the laser transmission welding is one of the good option for the joining between the dissimilar plastic to metal. So, in this module we have discussed that different welding techniques, several issues, advantage, disadvantage, different application area for the welding and joining of the non-metals. However, there is a need for extensive review of works and till there is a so many other techniques can also exist specifically for the joining of the nanomaterials, but we have covered in a very few selective techniques in this case. Thank you very much for your kind attention.